Hello, good afternoon, friends. I'm very happy to be part of this workshop on sustainable road freight. I thank the organizers, in particular Professor Shankar Ram and Karthik, for reaching out and having me as part of this very exciting and important event. I'm Anshu Bharadwaj and I represent Shakti Sustainable Energy Foundation, a philanthropic organization based in New Delhi. Shakti is a philanthropic non-profit, and we work in areas which are important for our country's clean energy and climate perspective. We use philanthropic grants to engage with a large number of think tanks and academic research institutions to work in policies that promote the uptake of clean energy technologies. Our areas of work include clean power, energy efficiency, sustainable transport, climate policy, climate finance, etc. Um, we also have an electric mobility initiative, which is a multi-funder initiative attempting to promote electric mobility in our country. The EMI has four main pillars. One is looking at the manufacturing ecosystem for electric vehicles and also batteries. Second is how we can bring the costs down. So looking at adoption and uptake by the consumers. Third is building more consumer awareness about electric mobility. And finally, addressing issues in charging infrastructure. Our EMI program is led by Narayan and also includes team members in Suchitra, Preeti, Priyadarshini, and Trupti. We are also just beginning a program in zero emissions trucking, ZET, which Karthik is leading, and we will be shortly developing a work plan for this very important program. So, friends, in today's talk, I will talk about three main areas. Why freight is important, what technology options are available or possible to transition from the current diesel-based trucks to zero emissions trucks, and what policy actions are required to address the barriers. So let's talk about why freight is important. Now, this may be obvious to many of you, but still, for the sake of repetition, freight is the lifeline of a country's economy. Freight is what keeps the country ticking along by movement of goods from one part to another part. It's a huge employment generator and also a significant contributor to our GDP. In addition to that, it has important implications on the energy and emissions. Freight accounts for 90% of the country's diesel consumption, almost 80 billion liters. Freight accounts for about 200 million tons of carbon dioxide, which is about 10% of India's overall greenhouse gas emissions and about 70% of our transport emissions. So if we want to address transport emissions, we will have to address freight on priority. The graphic at the bottom just illustrates the fact that within freight, road freight is the largest contributor with about 70% of the tons kilometer. It also is the largest emitter in terms of carbon dioxide with 80 odd percent emissions share. And then more importantly, freight is rapidly growing. So as the economy grows, as India is targeting high GDP growth rate, it will come hand in hand with movement of freight across the country. So studies done by our partners have projected that freight demand is expected to grow 4 to 5 times in the next 3 decades. So the graphic on the left shows the energy demand, increase in energy demand, and the graphic on the right shows increase in freight emissions. So as you can see, the emissions are expected to grow to around 500 million tons or half a billion tons by mid-century if we continue with the current freight technologies of diesel-based engines. Now, as we know, India has made a pledge of net zero by 2070. So clearly, this increase in freight emissions is not consistent with what India has announced. Because if we have to achieve the net zero by 2070, then we would expect transport emissions and freight emissions to plateau at some point in the next maybe 2 to 3 decades and then start declining and eventually get to zero. So, but this trend shows a monotonic increase in emissions, which clearly needs to change. So something has to be done in transition to a zero emissions technology framework. So what options are there? Uh, as we try to move away from diesel-based trucks, I think there are four main technology options. One is biofuels, one is compressed natural gas or LNG-based systems, third is hydrogen fuel cells, and fourth is finally battery electric vehicles, BEVs. Now it's important to note that the first two, that is biofuels and CNG LNG, require the same engine, uh, effectively the same reciprocating engine with some minor modifications we can use for operating on biofuels and CNG or LNG. But when we talk about hydrogen fuel cells and BEVs, we're talking about very different and new technologies. So that needs to be kept in mind as we look at the various options. The other important point is that I feel in Indian conditions, we need more detailed engineering economic analyses or life cycle studies to compare these four options across various metrics. Uh, these studies have been done in the West, in US and other countries. I believe we need to do similar rigorous studies in Indian context with data to understand how these four options compare on various metrics and what makes sense for India. Uh, uh, Today, what I'll present is a sort of a qualitative assessment of comparing these four options. It's based on our judgment and our thinking. And because it is based on our judgment, it is subjective and open to criticism. You may have a different take on this, and I would be happy to hear your thoughts. But what I'll present is our interpretation of how these four options compare in Indian conditions. So what we have done is that we have taken these four options, which you can see on the four columns, and we have compared them on a few indices like technology maturity, carbon intensity, air pollution, and overall efficiency. So let me quickly run through this slide and explain this. Now, technology maturity, as I said, the biofuels and CNG or based systems effectively still use reciprocating engines with some minimum modifications as required. So I would say those technologies are fairly mature. BEVs are uh, early stage of maturity. I won't even say beginning to mature, uh, but a reasonable number of products are available, especially in Western countries. We have prototypes which are available, which have been demonstrated. So they're beginning to mature. Long time to go for cost maturity, but some products are available. Hydrogen fuel cells, I would say, are in nascent stage and lot more work needs to be done. Carbon intensity, well, in this case, CNG is clearly not an option because we don't gain anything. It's basically we are replacing diesel with CNG, which is largely methane, and so the carbon intensity remains moderate to high. Biofuels, in theory, they are carbon neutral, but really depends upon the type of biofuel which we are using. So we have to be careful here. Depends upon the type of biofuel, and therefore detailed life cycle studies are required to understand whether a biofuel really is carbon neutral or not. BEVs, again, at the point of emissions, there are no emissions. At the truck, there are no emissions. But it depends upon the electricity used in charging. If we use the current grid electricity, which has a grid emissions factor of 0.7 kg of CO2 per kilowatt hour, then of course we are emitting carbon dioxide somewhere in the grid. But as we progressively decarbonize, the grid eventually getting to zero, then BEVs become carbon neutral. Or if we use dedicated RE to develop a charging infrastructure, then it is zero emissions. And same goes for hydrogen. It all depends upon the source of hydrogen. If we use hydrogen from coal gasification or hydrogen from steam reforming of natural gas, we don't gain anything in terms of carbon emissions. But if it is from RE, then obviously it's zero emissions. Air pollution, of course, the new technologies, BEV and hydrogen, are winners because at the point of the truck, there are no emissions. Whereas in biofuels and CNG, because we have combustion going on, naturally there will be emissions of air pollutants. Efficiency. Now, in this, it's important to note I'm talking about tank to wheel efficiency, not well to wheel, it's just tank to wheel. In CNG biofuels, again, because it is a reciprocating engine, we are limited by the efficiency of a reciprocating engine, and which is modest, between 15 to 20%. BEVs, these efficiencies are very high because it is electric motor. Hydrogen fuel cells again have much higher efficiencies than reciprocating engines. However, we need to do this analysis on a well-to-wheel basis as well to have a more apples to apples comparison. Likewise, a quick slide. Again, we are now comparing the fuel cost, vehicle cost, infrastructure cost, etc. So let's look at vehicle cost. The new technologies, BEV and hydrogen, are extremely expensive. They are 5 to 6 times more expensive than the current technologies of a diesel engine. And that is a huge barrier to their adoption. This cost will have to come down. Likewise, BEVs, one of the constraints is charging. It takes time to charge the batteries, even with fast charging. And then the last issue is infrastructure. With new technologies, BEVs and hydrogen, we require a new infrastructure for charging the batteries and also for hydrogen distribution and refueling. So this just highlights the challenges in these 4 attributes. So what's the bottom line? My own sense is that we need more detailed analysis to understand which will be a winner in Indian conditions. So clearly CNG, LNG is not an option, right? Because first of all, we don't have enough of LNG. We'll be importing it largely. That's one. Number two, it doesn't solve the climate problem because there is almost no, perhaps only minimum reduction in CO2 emissions per kilometer. So this is clearly not an option. Biofuels, perhaps. But again, as I said, it depends upon the kind of biofuels. I also don't think that biofuels will be able to play a huge impact, but because please remember, we are talking about 80 or 90 billion liters of diesel. I don't think we'll be in a position to produce that amount of biofuel using our land resources. At best, biofuel will perhaps contribute a small fraction of the future demand, but only a small fraction is my sense. So that really leaves us with BEVs versus hydrogen. Now, I think the jury is still out. If you talk to various people, we get different voices. Some people say that for long distance trucking, hydrogen is the way to go. Other people counter that and say that for long distance trucking, BEVs is the way to go. Even within policymakers, we hear different voices. So I think over time we'll get to know. Perhaps market will tell us. The OEMs are the best. I mean, they are in best position to tell which technology works in Indian conditions. and I think scene will become clear over the next few years. We in Shakti, of course, are working more on BEVs. We have a zero emissions tracking program which is largely focusing on BEVs, which Karthik is leading, and we are trying to address some issues in BEVs. So I'll just share very quick insights from that program. One is on the economics. So we looked at a high HDT, which is running between Delhi, Bombay, and one of our partners did this analysis. So even though the capital cost of this truck is very high, it's almost 6 times the cost of a normal diesel engine truck, the operating costs are much lower. And so on a total cost of ownership basis, they found that these trucks achieve cost parity within 4 to 5 years. So it's reasonable, and there is merit in going for these options because of the TCO basis. What are the challenges faced by BEVs? We broadly look at 3 sets of challenges. One is on the manufacturing side, high capital cost, high import duties on components, large battery size, awareness and adoption, range anxiety, technology apprehensiveness, and a small number of products. Charging, we need to develop a charging infrastructure. It requires investments. Um, any foray into BEVs needs to go hand in hand when looking at the electricity grid, how we will charge these grids, and also addressing the waiting time for charging. So we also looked at possible policy enablers. I think as far as manufacturing goes, at some point government will have to step in and announce some fiscal incentives to OEMs. Some policy initiatives will be required in the initial stages, very similar to what we did for the solar industry maybe 8 or 9 years back. So something to get the market going and before OEMs take over. Standards and regulations need to be set to be for these trucks. Awareness and advocacy campaigns. I think we need some success stories. So if we are able to demonstrate pilots across a few corridors and prove that this technology works, I think that will go a long way in convincing the OEMs and the consumers. And lastly, charging. So while we do need to develop charging infrastructure, we also need to look at the supply side for RE integration. This RE needs to go hand in hand with deployment of ZETs. Otherwise, we'll be shifting to the coal-based grid and not solve the climate problem. Lastly, I'll just one slide on what we are doing in freight. It is just we are beginning to do work in freight areas, and Karthik is leading this effort. Our work focuses on developing coalitions for transition in freight electrification. We are looking at industry studies, in particular in 3 areas: cement, dairy, and mining. We are also looking at pilot runs in some corridors to study the impact on emissions, fuel, and costs. So initial days, but we'll learn as we go along, and we would be happy to work with partners in this effort. So with this, I conclude. I thank the organizers for inviting me to this workshop. Would be happy to engage with you in discussions. I also thank my Shakti colleagues, Narayan, Preeti, Suchitra, Priyadarshini, and Trupti, for helping me prepare this today's presentation. Thank you very much.